Welcome back, folks. In this video, I'm going to talk about the Chebyshev theorem. A Chebyshev theorem is used when the data is not normally distributed. So what is non-normally distributed data? So normally distributed data looks something like this, a bell-shaped curve. So what if the data is not normally distributed? For example, if the data looks something like this, this is right skewed data, or the data is left skewed. So if it is something like this, skewness will be in the direction where the tail is. So the tail is on your left hand side, this is your right hand side, so the skewness is on the left hand side. So this is left skewed data, and this one is right skewed data. Okay. Now, this kind of an example happens generally when when something doesn't follow the normal distribution graph. So one example can be, for example, what age people generally get hospitalized. So generally, if I say assuming that people live from 0 to 100 years, so you can easily say that people generally gets hospitalized later in the life. I'm not saying the people are not going to get hospitalized early in their life also, but generally it's been seen that majority of the people, when they get into the older stages, then they get hospitalized. So that can be a prime example of left skewed data. All right. Now, in that scenario, when the data is not normally distributed, then we use the Chebyshev theorem to find out what percentage of the data lies within the K standard deviation. So it says the percentage of the data within the K standard deviation of the mean can be figured out by this formula. So it has to be the percentage of data around the mean must be greater than percentage of data around the mean must be greater than equal to 1 minus 1 upon k square. So for example, k, first of all, k is the number of standard deviation. For example, if the number of standard deviation is 2, what percent of the data lies within 2 standard deviations? If the data is not normally distributed. So let's see. So the percentage of data within two standard deviations should be greater than equal to 1 minus 1 upon 2 square. So greater than equal to 1 minus 1 upon 4, and that's going to become 1 minus 0.25, which is 0.75, or you can say 75%. Minimum 75% of the data should lie within 2 standard deviation if the data is not following the normal distribution graph. So something like if data is following a graph like this, in this one, within 2 standard deviations, minimum 75% of the data should lie. When it was following a normal distribution, what did we say? 95% of the data. But if it is not following a normal distribution, it will become 75% of the data within 2 standard deviation. And one thing we also said that k must be greater than 1. K can be 1.1, but it cannot be 1. Okay, it must be greater than 1. So now, based on this concept which we've learned, we're going to try and solve 1 or 2 questions here. So a population of scores is non-normally distributed around the mean 7.80. Is the mean value is 7.80. Standard deviation sigma is equal to 0.56, and at least what percent of the scores will fall between 6.12, x value is 6.12, and 9.48. Okay, just one thing I want to tell you, these questions which I'm doing with the pen means with this writing pen, I will highly recommend you guys rather do it by typing. Like for example, mean, you will write it here 7.80, and then sigma means standard deviation is equal to 0.56. If you want, you can add the notation of sigma also. It will be under the home page. It just says the auto turn is on, so I wanted to remove this, but anyhow, so standard deviation is here, and then what else is given to me? X value, lower limit, I'll call it lower limit, and that is 6.12, 6.12, and x upper limit, UL, that is 9.48, and the formula we're gonna use, again same formula we're gonna use for lower limit, which we used in the uh, empirical formula, normal distribution graph. X or mean minus k times standard deviation. This is the formula which we use for lower limit. Upper limit, we're gonna use mean plus k times standard deviation, ST. Now let's look into the question. Population score normally distributed, mean is given to a standard deviation. At least what percentage of the scores will fall between 6.12 and 9.14? So we wanted to find the percent of data lies between these 2 points. So first of all, we need to find out the k value. Okay, for lower limit, the k value is 6.12, and which is equal to mean minus k times standard deviation. This is what I'm going to use. I'm going to write it here. So equal to mean value, which is 7.80 minus, well, I shouldn't be putting equal to here, so that otherwise you won't be able to understand easily. K times, I will write it 0.56. All right, and you can keep a pen and paper with you to solve it on paper, and then do the math later on here. So this gonna go on the other side, equal to 6.12 minus 7.80. That's gonna give me this, equal to minus k times ST. All right. Whoops, I shouldn't have put equal to here, and k times 0.56. I should write it as 0.56. All right, and shouldn't be putting equal to here. I think it's automatically taking the, see, it's let's see. Yeah, so I will leave it as, what shall I do? I'll put a quotation like this here. Okay. If not this quotation, then I'll leave single quotation. Let's see. I'm not using formula. I think this minus is kind of creating a problem here. It's just not allowing us to move any direction. Anyhow, I'll leave it as k here, see? And there is a negative here, you might have noticed, so I will remove the negative from here in the next step. 1.68. You can do this calculation on the paper and just write down the answer here, you know. So because I understand majority of you guys don't have the stylus to write here, so I'll make it easy for you. So only for these kind of questions where there is normal distribution or there is this Chebyshev theorem, equal to here k value, just okay, this number 1.68, This is hard. Divided by 0.56, and that's k value is 3 on the left hand side. Now the other hand side, I'll just directly do it here. You can do this method also. 6.12, the other is 9.14, 9.48 minus 7.80 and divided by 0.56. That's gonna give you the k value also, upper limit. Let me just put a small k, upper limit ul, but mention everything, guys. So, and this is lower limit. All right, so we got the values. Let me just color it up, and this one home, and this is this one. All right, so we got the lower limit and upper limit, and now we just need to find out what percent of the data. K value is 3 on both the sides, and majority of the times when you are using the Chebyshev theorem, it will be same K value you're gonna get. Okay, and now let's find out what percent of the data. So 1 minus equal to 1 minus 1 divided by 3 square, 3 to the power of 2, close the bracket, which is 0.88 in percentage of the, let me say, percentage of data is equal to this times it by 100. So 88.89% equal to round 88.89% of the data is under the 3 standard deviations, or will fall between 6.12 and 9.48. So hopefully you were able to understand. So I will highly recommend you to try and do the part B also, and try and figure out what you're gonna get for your result. I think it will come out to be approximately 75% of the data, because this looks like one less standard deviation. This on the other side also one less standard deviation. Let me just quickly see the numbers 1 second. Equal to 8.92 minus 7.80 divided by 0.56. Yeah, 2 standard deviation. Same thing gonna go for the other side also. So 2 standard deviation, which will be 75% of the data. So hopefully you were able to understand this question. Yeah, that's about it for Chebyshev theorem. I will see you with another video. That will be the last topic for chapter 3. Till then, goodbye.